Hey guys, Chapter 2, Section 3 video here for you today. We are going to work on how do I combine rational numbers. So this is not something new to us. We are already working on this a little bit in class, but we're going to continue our work in this video. So let's talk about what a rational number is. By now you should be really comfortable with those words, rational numbers. A rational number is just a fancy way of saying we're talking about fractions and decimals. Fractions, decimals, or percents. And specifically, we're talking about ones that can be positive and negative. So we're not talking about regular fractions and decimals. We're talking about having positive and negative fractions and decimals. And what we want to be able to do is we want to be able to add, subtract, multiply, and divide those rational numbers. And it takes a lot of work. It takes a lot of thought process, actually. So to kind of get this video started, we have a little situation here I want you to think about. You eat 3/8 of a pie and your sister eats 1/4 of the pie. Explain who ate more of the pie. Take a moment here and pause the video. I want you to think about this question and come up with your own answer. Go ahead and try. Okay, so you eat 3/8 of a pie and your sister eats 1/4. Well, I'm a visual learner. I like to see things. So here we have two circular pies. One of them I've cut into 8 slices and one of them into fourths. If you eat 3/8, then you're eating 3 of those slices. And if your sister eats 1/4, then she's eating 1 of those 4 slices. So who ate more? You did. 3/8 is bigger than 1/4. You can see it. 3/8 is definitely bigger than 1/4. So you ate more of the pie. 3/8 and 1/4 are rational numbers. They are fractions. That's all they are. So keep in mind whenever we're thinking of fractions to think of it as parts of wholes. You want to keep that in your head, parts of wholes. So let's try some examples now where they get a little more complicated. We are going to solve this problem. -2 and 2/3 take away 4/10. -2 and 2/3 take away 4/10. I see negative numbers, so I know I'm going to need to use my integer rules. But I also see fractions, so I know I'm going to need to use my fraction rules. And the fraction rules say if we're going to add and subtract, we better get rid of that mixed number. That 2 and 2/3 needs to be rewritten. So what do? Well, 2 times 3 is 6, plus 2 on top makes 8. So this is 8/3. And the 4/10 is great. It can stay as 4/10. But what are my fraction rules? Fraction rules say if you're adding and subtracting, you have to have a common denominator. We do not have a common denominator right now. So I'm going to use the butterfly trick where I'm going to make a common denominator. I know that 3 times 10 would be 30. So I'm going to have a common denominator of 30 on the bottom. 8 times 10 is 80, and 3 times 4 is 12. So I have 80/30ths and 12/30ths. Now I've got my common denominator. But here's the next step. The next step after this is I have to use my integer rules. This is a KCC problem. I see subtraction. I need to keep, change. That means I'm going to keep that negative sign. I'm going to change the minus to a plus sign. And then 4/10 will change to a negative 4/10. So now I have -2 and 2/3 plus negative 4/10. Same signs add and keep, different signs subtract. I'm going to go to my rules. Same signs add and keep. These are the same signs. They are both negative. -2 and 2/3 and negative 4/10. So our rule is to add and keep, which means we get to add 80 plus 12, which is 92/30ths. But add and keep means I got to keep it negative. The answer is going to be negative 92/30ths. And I'm pretty much done with this problem, except for one little thing. I'm going to zoom out so you have some more space here. I need to simplify. Negative 92/30ths totally simplifies because 30 fits into 92. In fact, count by 30s. 30, 60, 90. You can fit 3 of them in there. 90 is close to 92. So the simplified answer is it's -3, and there'd be 2 remaining, 2/30ths. And even more simplified than that, -3 and 2/30ths, I could divide the 2 away. I could divide by 2 to simplify the fraction down to -3 and 1/15. And that is my final answer, -3 and 1/15. Take a look at all this work that we just did. We had to do all the things we know about fractions, getting common denominators, rewriting the mixed number, simplifying the fraction, and then we also had to use our KCC integer rules. So, I mean, there's kind of a lot going on in these problems. Let's try another one, example 2. 7 1/2 take away -2 and 5/6. 7 and 1/2 take away negative 2 and 5/6. So remember what we like to do first, get rid of the mixed numbers. So 7 and 1/2 is like 7 times 2, well, that's 14, plus one more on top is 15. So we have 15 halves. Let's get rid of the other mixed number. 2 times 6 is 12, and 12 plus 5 more on top gives me 17. So 17 sixes. We want to get rid of those mixed numbers. Now I look for a common denominator, and I don't have one. So butterfly it. We're going to do 2 times 6 on the bottom to get 12 as our common denominator. And then we got to multiply. And if you need to grab a calculator for 6 times 15, that's fine. That doesn't really bother me too much. 6 times 15 is 90. And 2 times 17 is 34. So there we go. We got common denominators of 12s, and we got 90 and 34. Now we got to go to our integer rules. And this is another KCC problem. It's takeaway. We are going to keep change. We're going to keep 7.5 positive. But then we're going to change it to adding. And we're going to change it to a positive 2 and 5/6. So now it looks like we are adding them together, and I see same signs. I see them both positive, so same signs, add and keep. So we're going to be add and keeping these fractions. 90 plus 34 is 124 twelfths. 124 twelfths. I'm going to zoom out again. Okay, so 124 twelfths. How many 12s go into 124? Let's count by 12s on the side over here. Look what I did. I made a list. 12, 24, 36, 48, 60, 72, 84, 96, 108, and 120. Look how close to 124 I got. That's counting by 12s. So how many of those 12s are there? Well, there's 10 of them. So it looks like our answer is 10 and 4 leftover 12s. 4 would be the remainder, and I can divide this down by 4 to simplify it. So 4 divided by 4 is 1, and 12 divided by 4 is 3. So it's really 10 and 1/3, and that is my final answer, 10 and 1/3. Okay, so again, we have to use our integer rules. We have to get rid of mixed fractions. We have to get common denominators, and we have to simplify. There are a lot of steps involved here. Why don't you try one and see if you can do it without help? These take practice. So here is your problem. Negative 9 and 6/7 take away negative 5 and 1/2. Right now, on your device, hit the pause button and see if you can do this all by yourself. All right, let's check your answer and see how we're doing here. So we're going to get rid of these mixed numbers. First, I got to do 9 times 7 plus 6. That would be 69 sevenths. I hope that's what you got too. And the 5 and 1/2 would change to 11 halves. And we do not have common denominators, so we're going to butterfly it. 7 times 2 means our common denominator is going to be 14. 2 times 69 is 138, and 7 times 11 is 77. There's our fractions. Wow, that took a little bit of work. Okay, so now time for the KCC rule. We're going to keep change. We're going to keep the negative 9 6/7. We're going to change it to a plus, and we're going to change it to a positive. So what does that mean? That means we have different signs. One of them's negative, one of them's positive. So it's same signs, add and keep, but different signs, subtract. This is a subtraction problem. We are going to take away 138, take away 77, and that is 61 14ths. Now the bigger number out of the two fractions is negative 9. So because of that, it's negative 61 14ths. Now count by 14s. How many 14s can go into 61? Well, 14 plus 14 is 28, plus 14 is 42, plus 14 is 56. So it looks like 4 of them. It looks like we have negative 4 with 5 remaining 14ths. So your answer, I hope that you got, was negative 4 and 5 14ths. Check your work. Did we get the same thing? Did you make a mistake? And if you did, where is your mistake? Look for it. That way you don't do it again next time. All right, so to wrap up our video, you should write this down at the end of your notes. Adding and subtracting fractions takes kind of 3 main things. You have to have common denominators, you have to use your integer rules, and then you have to simplify your final answer. So there's a lot of different stuff going on here. And that kind of wraps up how we add and subtract these rational numbers when they look like fractions. Thanks for watching, guys. There's going to be more on this later.